Hey everyone, so for this video, I want to eventually get to the point where we talk about solving quadratic equations, but first we have to do some background information, some background work. So we need some definitions. We're going to talk about what a monomial, binomial, trinomial are. We're going to talk about multiplying two binomials. We're going to talk about factoring trinomials into the product of two binomials. We're going to talk about what is a quadratic trinomial. And then we're going to get to the point where we talk about quadratic equations, okay? This is a very long section, so the video is going to be a little lengthy, okay? But it's a lot of information. It's all very important. So just heads up, it's a little bit lengthy. You'll be fine. All right, so let's go to the whiteboard. So I am on my tablet, which is good because it's a little less messy, but it does take it's a little awkward getting started, okay? Okay. There we are. Okay, so first of all, I want to give you a couple of definitions. So remember algebraic expressions. We talked about algebraic expressions in a previous section, and basically it's constants and variables mixed with operations. So adding, subtracting, multiplying, dividing, and potentially exponents, okay? So if you have a monomial, and this is not on your worksheet, but this is just kind of for your own information. A monomial is an algebraic expression that simplifies to a single term. Okay, we then have what's called a binomial. We're going to talk a good bit today about binomials. So a binomial is an algebraic expression that simplifies to two terms. And then about halfway down the first page of your worksheet, there is the definition of a trinomial. I'll bring it back up when the time comes, but I just want to kind of group these together for the moment. You then have a trinomial, which is an algebraic expression that simplifies to three terms. Now, I will tell you this, I'm getting a little footloose and fancy free with these definitions here. These are not very formal definitions by any stretch of the imagination. I just want to give you a general idea of a monomial, binomial, and a trinomial. I do want to make sure that you understand that the exponents on variables would all have to be nice, pretty whole numbers. So your exponents wouldn't be negative or fractions or anything like that, okay? So these three definitions, we're going to talk about especially binomials and trinomials throughout this worksheet, okay? So that's kind of going to give us a nice little start. Now, one thing that we have to learn how to do is multiply two binomials. So multiplying two binomials. So think bi for two, tri for three. That's how you can keep straight the difference between a binomial and a trinomial, okay? So let's consider this. So let's say we have ax plus b times cx plus d. Let's say that's our two binomials. We multiply binomials using the FOIL method. So we use the FOIL method. F in FOIL stands for first terms. And basically what the FOIL method does is it gives us an order to multiply our terms in so that everything gets multiplied together and then we would simplify. So if we're looking at ax plus b times cx plus d, the first terms would represent the first terms in both expressions. So ax and cx. So we would multiply those together. Then we would multiply the outer terms. So O for outer. And this represents the two terms that are kind of on the outside of the two expressions. So ax and d. Once we multiply those terms, we would then want to multiply the inner terms. So think I for inner. And that would be the two terms kind of in the center of the expression. So that would be b and cx. And then finally, we would multiply the last terms. And the last terms represent the last terms in each expression. So this would be b and d. So what we do is we multiply in this order and then simplify when possible. And I find that most students are pretty okay at this. This isn't something that the general student struggles with a ton. I do encourage you to be very careful, make sure you fully distribute and watch your signs. Okay, so let's look at two examples. So the first one, we would multiply x plus 5 times x plus 6. So I start with the first term in the first binomial. I'm going to call that x, okay? I'm going to distribute it through the second set of parentheses. So I would multiply x times x, which is x squared, and then I would multiply x times 6, which is 6x. I'm done with the x in the first binomial. I'm going to go and pick up the 5 in the first binomial. And then I'm going to distribute the 5 through the second set of parentheses. So I would get 5 times x is 5x, and 5 times 6 is 30. So let's look at this a little slower. If I look at the x times the x, those are my first terms, okay? If I look at the x times the 6, I get 6x, those are my outer terms. If I look at the 5 times the x in the second set of parentheses, I get 5x, and those are my inner terms. And then if I look at the 5 times the 6, I get 30, and those are my last terms. So I have completed the FOIL process, and now all I want to do is combine like terms where possible. If I look here, 6x and 5x are like terms. I would simplify those, and my final answer would be x squared plus 11x plus 30. And this is the final answer, okay? So that is multiplying two binomials, okay? When you multiply two binomials, you could get it to simplify to another binomial. In many cases, it'll simplify to a trinomial. Sometimes it could simplify to a polynomial in 4 terms. A polynomial is just an algebraic expression with more than 3 terms, okay? Let's do one more of these. Let's say this time we multiply 7x plus 5 times 4x minus 3. So again, I'm going to start with the first term in the first set of parentheses, and I'm going to distribute it through the second set of parentheses. So I get 7x times 4x. 7 times 4 is 28. X times x is x squared. I then take 7x times negative 3. Watch your signs. 7 times negative 3 is negative 21. And then I keep the x. I'm done with 7x. I now need to take the second term in the first binomial and distribute it through the second binomial. So I'm going to take the 5 and distribute it through 4x minus 3. So 5 times 4x, I get 5 times 4 is 20, keep the x. And then 5 times negative 3 is negative 15. So again, I multiplied my first terms, outer terms, inner terms, last terms. And we want to see if things will simplify. Well, yes, the x terms will combine. So I'm going to start with 28x squared. And then if I look at negative 21x plus 20x, those are like terms. I would take negative 21 and add 20. I get negative 1. Negative 1 times x is just negative x. And then don't forget your minus 15. So there is your final answer. Okay. So now on your worksheet, you can see we officially introduce the definition of a trinomial. So you can see that for a trinomial, it's a simplified algebraic expression that contains 3 terms in which all variables have whole number exponents. So you already have that definition. I want to give you an example of that. Let me go back to black ink. So an example of a trinomial would be something like 5x squared plus 2x plus 1. Further, this is specifically a quadratic trinomial because, and this is not really on your note sheet, I'm just sort of supplementing the definition of trinomial by giving you a very specific example, but this is specifically a quadratic trinomial because it is in the form ax squared plus bx plus c, where a, b, and c are real numbers, where a is not equal to 0. So let's kind of unpack that. So we have the definition of a trinomial, a simplified algebraic expression that contains 3 terms in which all variables have whole number exponents, okay? The example I give you is 5x squared plus 2x plus 1. Now we can take the definition of a trinomial one step further in this case. And I say this is specifically a quadratic trinomial because it is of the form ax squared plus bx plus c, where a, b, and c are real numbers. That means they can be whole numbers, they could be integers, that means positive, negative, they could be decimals, they could be fractions, any numbers. The only condition is a cannot be 0. And the reason for this is we call it a quadratic trinomial because the highest exponent is 2. So what makes it quadratic is the fact that the highest exponent is 2. So we do not want a to equal 0, because if a equals 0, that first term, a times x squared, would just become 0, and it would no longer have the highest exponent of 2. Okay, so for this to be quadratic, we have to have a squared term in the trinomial. Okay, a lot of times we would call this a second degree polynomial. Okay, so just know that a refers to the coefficient of the squared term, B refers to the coefficient of the linear term, C refers to the constant. So I'm going to write that out. A is the coefficient of the squared term. B is the coefficient of the linear term. And by linear, we mean just x with an exponent that's just 1, so you don't have any other exponent. And C is the constant. Okay, and that's going to come up a lot throughout this video. Okay, so kind of keep this information right here and understand how it applies to this information right here. Okay, so here's what we're going to learn how to do. We're going to learn how to factor quadratic trinomials, so ax squared plus bx plus c, but this time we're going to look at them where a is exactly 1. So factoring ax squared plus bx plus c, where a is exactly 1. Okay, now you could have situations where a is not 1. We're not going to learn how to factor those because that's a little bit more elevated. It's a higher level of thinking. That would be something that would come up in like an algebra class, like tier 3 of math 003 or math 121, 171. We don't have to go that deep. We just have to learn the basics. Okay, so first of all, what is factoring? So our goal, and this is not on the worksheet, so you can fill this in. The goal is to rewrite ax squared plus bx plus c as the product of 2 binomials. So basically, factoring is kind of like the algebra equivalent of dividing, and it will undo multiplying binomials or multiplying monomials and binomials. But for us, we're just going to learn how to undo the FOIL method here. Okay, so we have 4 steps. All right, and I'm going to do the 4 steps on the next page. Okay, so again, factoring ax squared plus bx plus c. Again, I want to be really clear. We're doing this where the coefficient of the squared term is exactly 1. If the coefficient of the squared term is not 1, it's just a higher level of thinking. It's a more complicated process. We don't have to worry about that here. And again, what we're really doing is we're learning to undo the FOIL method for multiplying 2 binomials. Okay, so again, we'll look at this on the next slide. Okay, so 4 steps and then a note. All right, so first of all, we're going to consider this. So we're going to consider x squared plus 7x plus 12. That's going to be kind of our example we use as I go through these 4 steps. So here's your first step. Enter x as the first term of each factor. So when we're talking about factors here, factors are things that we multiply. And remember, from the previous slide, we're right here factoring ax squared plus bx plus c. The goal is to rewrite, so we're right here. The goal is to rewrite ax squared plus bx plus c as the product of two binomials. So product is the answer to multiplication, and factors are things that are being multiplied. So we want to basically start out, let me go back to black ink, sorry, whoops. We want to start out with two sets of parentheses for our binomials, and we're going to start each one with an x. Now, we need to find a way to multiply to get x squared. Well, if I take x times x, what do I get? I get x squared. Okay, so that's our first step, is just start your two sets of parentheses with an x. Okay, the second step is find two numbers that multiply to c, remember c being the constant, and add to b being the coefficient of the squared term. So remember, when we're talking about a, b, and c, we're looking at this stuff right here. A is the coefficient of the squared term, b is the coefficient of the linear term, or just x, and c is the constant. And that's always going to be the case when we talk about quadratic stuff, okay? So we're looking for two numbers that when we multiply them, they multiply to give us c, the constant, but they simultaneously add to give us b, the coefficient of the linear term, or just the coefficient of x. So let's look at 12. How do you multiply and get a positive 12? Well, you can multiply two positive numbers, or you can multiply two negative numbers. So we got to get a positive 12 here. So we could multiply 12. Whoops, let's go back to black ink. We can multiply 12. Good gracious. I'm just going to leave it blue. At this point, it seems determined. We can multiply 12 and 1. We can multiply negative 12 and 1. We can multiply 6 and 2, negative 6 and negative 2, or 4 and 3, or negative 4, negative 3. So what we're looking for is we're looking for the pair of factors, that's numbers that you multiply, that when we multiply them, we get 12, but when we add them, we get 7. So which pair of numbers here in blue do we multiply to get 12, but we add to get 7? Well, if I multiply right here, negative 4 times negative 3, that does multiply to give me 12, but it doesn't add to give me positive 7. If I multiply here, 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 and here, I get 12, but I don't get a sum of 7. So this one right here is kind of like from the three bears. This is the one that's just right. If I multiply positive 4 and 3, I get 12. If I add 4 and 3, I get 7. So what we're going to do is we're going to fill in for step 3. We're going to place those two numbers as the second term of each of those factors that we started in step 1. So place those two numbers as the, second term, of each factor. So again, we have the factors as x plus or minus something times x plus or minus something else. But this time we're going to add 4 and we're going to add 3. Okay, so now we have two binomials. We hope that when we multiply this out, we get x squared plus 7x plus 12. And that is the fourth step. So check your answer using FOIL. All right, so we have x plus 4 times x plus 3. We're going to start with the x in the first binomial and distribute it through the second. So x times x is x squared. And then x times 3 is 3x. I'm done with the x. I'm going to go and pick up the 4 and distribute it. So 4 times x is 4x. 4 times 3 is 12. And then you always want to look to see if you can simplify, and we can. Okay, so this equals x squared plus 7x plus 12, which is exactly what we want. Okay, and then there is one last, it's not really a step, it's just something to make note of. If you have a trinomial where you cannot find factors of c, or two numbers that multiply to give you c that also add to b, we would say that trinomial cannot be factored, and we would call it prime. So if a trinomial cannot be factored, we call it prime. So again, that would mean there are not two numbers that multiply to give us C, the constant, and simultaneously add to give us B, the coefficient of the linear term. Okay, so they happen from time to time. You don't get tons and tons of prime trinomials, but they will show up every once in a while. Okay, so here's what I want to do on the next page. Your worksheet has 3 examples of factoring. So we'll do 3 examples. And then I've got a few additional ones just for practice. I'll go ahead and do them right now instead of waiting till the end of the video. But if you feel comfortable after the 3 examples in the worksheet, just fast forward through the extra examples, okay? So examples. We want to factor x squared plus 5x plus 6. Okay, so we start 2 sets of parentheses for our 2 binomials. Hold tight, let me get a sip of water. I should really pause the video when I do this, but I don't, so love it or hate it. All right, so we started our 2 sets of parentheses for our binomials. And if we go back to the previous slide, step 1 right here tells us to enter x as the first term of the 2 factors. So let's do it. We're going to enter an x and an x. And then step 2 says find factors or 2 numbers that multiply to give us C, but add to give us B. So let's look at the factors of 6. We have a positive 6. There are 2 ways to multiply and get a positive 6. You can multiply 2 positives or 2 negatives. So we could have 6 and 1, negative 6, negative 1. We can have 3 and 2, or we could have negative 3, negative 2. Now, all 4 pairs of numbers multiply to give us positive 6. We want the magic pair that add up to be positive 5. So 6 plus 1 is 7. Negative 6 minus 1 is negative 7. Negative 3 minus 2 is negative 5. 3 and 2, however, is that little bears example that's just right. So what we do is we go down here to our 2 factors and we fill in a plus 3 and we fill in a plus 2. So this is our final answer. But let's go ahead and check it. So I've got x plus 3 times x plus 2. I want to multiply this out using the FOIL method to make sure that I really do get x squared plus 5x plus 6. So I'm going to start with this x right here. X times x is x squared. X times 2 is 2x. I'm done with the x in the first binomial. I'm going to pick up the 3 and distribute it. 3 times x is 3x. 3 times 2 is 6. Clean it up if you can. We do have a 2x and a 3x that can combine. So I get x squared plus 5x plus 6, which is exactly what I would expect. All right, let's try another one. So what if I have, whoops, I was about to jump straight to the answer. What if I have x squared plus 3x minus 10? Okay, so just like before, the first step tells us to start 2 binomials, each with an x, done. Now we want to find factors of negative 10. So ask yourself, how do you multiply 2 numbers and get a negative? Well, when you're multiplying 2 numbers and you want a negative product, one number has to be positive and the other one has to be negative. So let's look at numbers that multiply to give us negative 10. So we could have negative 10 and 1, or we could have 10 and negative 1. We could have negative 5 and 2, or we could have 5 and negative 2. Okay, so we want to find, we know all 4 of these pairs of numbers multiply to give us negative 10, but we want to find the pair that when we add them, we get positive 3. So negative 10 and 1 is negative 9. That doesn't work. 10 and negative 1 is positive 9. That doesn't work. Negative 5 and 2 is close. We get negative 3, but we don't want negative 3. We want positive 3. So again, the little bears or the 3 bears example that's just right is going to be 5 and negative 2. So we would fill in a plus 5 and a minus 2. And one more time, let's check our work just to make sure we're on the right track. So I have x plus 5 times x minus 2. We're going to check by FOIL. So we're going to start with x and then distribute it through the second binomial. So x times x is x squared. X times negative 2 is negative 2x. I'm done with the x in the first binomial. I'm going to pick up the 5. 5 times x is 5x. 5 times negative 2 is negative 10. And we definitely want to combine like terms if we can, and we can. We have a negative 2x plus a 5x in the middle that could simplify. So this simplifies down to x squared plus 3x minus 10, which is exactly what we want. Okay, So let's look at another one. This time we have the same directions apply. We're going to factor, and it's x squared minus 8x plus 32. So we start two binomials with an x, and now we're looking for factors of 32. So remember, to multiply and get a positive number, you can multiply two negatives or two positives. So I could multiply 32 and 1, or negative 32. Let me erase that and start over. Or negative 32, negative 1. I could have 16 and 2, or I could have negative 16 and negative 2. 3 doesn't go into 32, but 4 does. I could have 8 and 4, or I could have negative 8, negative 4. Okay. I can't do 5, I can't do 6, can't do 7, back to 8. Okay, so these are all of your factors, or all of the numbers that multiply to give us 32. Now let's find the magic pair that adds up to negative 8. Okay, well, 32 and 1 is 33. That doesn't work. Negative 32, negative 1 is negative 33. That doesn't work. 16 and 2 is 18. That doesn't work. Negative 16 and negative 2 is negative 18. That doesn't work. 8 and 4 is 12. That doesn't work. Negative 8, negative 4 is negative 12. That doesn't work. So at this point, you might be saying to yourself, oh dear, what do we do? Or is it, so this is a situation where we have no numbers that multiply to give us 32 that would simultaneously add to give us 8x. So we come and we look here. If a trinomial cannot be factored, we call it prime. So this example right here, we would say it is prime. There are no numbers of 30, or there are no numbers that multiply to give us 32 that also add to give us 8. Okay, so this one just can't be factored. Okay, so those are the three examples on your worksheet. I'm going to do some additional examples. So if you feel comfortable with factoring, you can skip through the next few examples. If you want to see some more practice, you can see some more practice right here. So the directions are the same. We're just going to factor. So I have x squared minus 2x minus 15. We're going to start two binomials, each with an x. And now we're looking for factors of negative 15. So that means one positive, one negative. We want those factors to add up to negative 2. So we could have negative 15 and 1. We could have 15 and negative 1. We could have negative 5 and 3, or we could have 5 and negative 3. So again, let's go through. They all add up to, or they all multiply to give us negative 15. We just have to find the pair that adds to be negative 2. Well, negative 15 and 1 is negative 14. 15 and negative 1 is positive 14. 5 and negative 3 is close. It's positive 2, but we want negative 2, right? So then negative 5 and 3, when I add those, I get negative 2. So that pair is just right. So I subtract 5 and I add 3. And again, if you want to check it, you don't always have to check it once you get comfortable with the process. But if you do check it, you just multiply this out using the FOIL method. So x times x is x squared. X times 3 is 3x. 5 times x is, or negative 5 times x is negative 5x. Negative 5 times 3 is negative 15. Clean it up, and we get x squared. $36. Just like the previous examples, we start two binomials, each with a factor of x. And now we're looking for factors of negative 36, and we want those factors to add up to be negative 9. So there are two ways to multiply and get a negative 36. We could do negative 36 and 1. We could do 36 and negative 1. We could do, let's see, negative 18 and 2, 18 and negative 2, negative 12 and 3, 12 and negative 3. Does 4 go in? So negative 9 and 4, 9 and negative 4. 5 doesn't go in. 6, so we could do negative 6 and 6. Okay, so those are all of the different pairs of numbers that when I multiply them, I get negative 36. Let's find the pair that adds to negative 12. Okay, well, negative 36 and 1 is negative 35. 36 and negative 1 is positive 35. Negative 18 and 2 is negative 16. 18 and negative 2 is positive 16. Negative 12 and 3, there you have it right here. If I add negative 12 and 3, I get negative 9. So I would go minus 12 plus 3. And if you want to check it, this will probably be the last one I check just for the sake of time. But you would check by just foiling the two factors you end up getting. So I get x times x is x squared. X times 3 is 3x. Negative 12 times x is negative 12x. Negative 12 times 3 is negative 36. Combine like terms, those middle terms do combine. So we get x squared minus 9x minus 36. And how satisfying is that? So again, that'll probably be the last pair that I check just again for the sake of time. Okay, so let's try another one. Let's say that we have x squared plus x minus 90. Sorry, I had to get another water break. So I start two binomials, each with a factor of x. And now I'm looking for factors or numbers that multiply to give us negative 90. So I could have negative 90 and 1 or 90 and negative 1. I could have negative 45 and 2 or 45 and negative 2. I could have negative 30 and 3 or I could have 30 and negative 3. Does 4 go into 90? If you don't know the factors like right off the top of your head, just divide on a calculator. 49 is not divisible by 4. 90 is divisible by 5. We get negative 18 and 5, or 18 and negative 5. Is 90 divisible by 6? Yes, so I get negative 15 and 6, or 15 and negative 6. Is 90 divided by 7? No. Is 90 divisible by 8? No. Is 90 divisible by 9? Hopefully this one's easy. Yes, we get negative 10 and 9, or 10 and negative 9. So now the question is, all of these factors multiply to give us negative 90. Which pair adds to be positive 1? Hopefully, as you're going through these, you're like, nope, that doesn't work, that doesn't work, that doesn't work. So I'll save you some time. None of these work. None of these work, but this one does. Okay, so we would fill in plus 10 minus 9. Okay, and again, if you want to check it, you can go ahead and check by doing the FOIL method. All right, one more example, and then we're going to move on to quadratic equations. For this one, we have x squared minus 14x plus 45. We start two binomials, each with a factor of x. And now we're looking for factors of 45. So to multiply and get positive 45, you're multiplying two negatives or two positives. So we could have 45 and 1, or negative 45, negative 1. We could have negative, let's do positive just to keep it consistent. We could have 15 and 3, or negative 15 and negative 3. We could have 9 and 5, or we could have negative 9, negative 5. And I think that's all of the factors of 45. So which pair adds to give us negative 14? So just to save you some time, again, as you're going through this list, hopefully you're like, that doesn't work, that doesn't work, that doesn't work, that doesn't work, that doesn't work. Bingo, that one works. So if I take negative 9 and I multiply it by negative 5, I certainly get positive 45. And if I take negative 9 and I add negative 5, I definitely get my negative 14. So there you have it. And again, if you want to double check yourself, you multiply those two factors using the FOIL method. Okay, so that's kind of the build up to quadratic equations. So now we're going to start the actual work on quadratic equations. Okay, there's really two ways we can solve these, and we're going to look at both. So again, this video is a little bit lengthy, but it's worthwhile. Okay, so definition: a quadratic equation in X, that just means the variable is X, is an equation that can be written in the form ax squared plus bx plus c. That should look familiar, but for it to be an equation, there has to be an equals. So we're going to set it equal to 0. Okay. I do want to add where a, b, and c are real numbers. Such that a does not equal 0. Again, if a equals 0, the x squared term disappears and it's no longer quadratic, because what is making this quadratic is the fact that the highest exponent is 2. So if the a makes the x squared term disappear, it's no longer quadratic, it would just be linear. We sometimes would call this a second degree equation. And one thing I will say, when you have a second degree equation, you get 2 solutions. So there are going to be 2 values for x that satisfy the equation. And graphically speaking, we're not talking about graphs yet. Graphs come in a later chapter. But graphically speaking, the solutions represent where the graph crosses the x-axis, oftentimes called zeros. So some of this information is not directly on your worksheet, but it is valuable information. So again, you've got the definition of a quadratic equation. The things I've added is what makes this a quadratic is the fact that the highest exponent is 2. We call it a second degree equation. When the highest exponent is 2, you do get 2 solutions, generally speaking, or you could have a situation where there's 1 repeated solution, or some rare examples where there's no real solution. That's not what we're looking at in this class. That's kind of like higher level algebra. So for us in this class, we'll get 2 solutions or at least 1 repeated solution. And again, graphically speaking, which you'll worry about this later in the semester, but when you're talking about a quadratic equation, those solutions have a meaning as far as the graph is concerned. There is a graph for a quadratic equation, and those solutions represent where you cross the x-axis, okay? Now, there are 2 methods for solving. There's actually more, but for us, there are 2 methods. The first is by factoring, and we're going to talk about that first since factoring is kind of fresh on our mind. And the second is using the quadratic formula. Okay, so let's talk about solving quadratics by graphing. Did I say by graphing? I definitely meant by factoring. All right, so solving quadratics by factoring, okay? There is a property or a principle that we need to use, okay? So there's something called the zero product principle. Your book calls it a principle, and other books I've used, it calls it a property. So if I accidentally say the zero product property, just know it's the same thing, okay? So we have the zero product principle. And it just states that if the product of 2 factors is 0, then one or both of the factors must be 0. Okay, so hopefully that kind of makes sense, because if we have a product, let's say A times B equals 0, we know from days gone by that if you multiply any number by 0, you get 0. So it goes without saying, hopefully, that if your product is 0, one of the factors has to be 0. So if AB equals 0, then A equals 0, or B equals 0, or both equal 0. So this is not on your worksheet, but just a quick example. Let's say I have x plus 5 times x minus 1 equals 0. We have our first factor, we have our second factor, and we have that they're multiplied together and their product is 0. So the way we would apply this is I would take each individual factor and set it equal to 0 and then solve. So set each factor to 0 and solve. That's kind of how you use the property. So if we were solving this equation here, we would take x plus 5 equals 0, we would subtract 5, and we would say, okay, x equals -5. over here, we would say that we're going to add 1 to both sides and we get x equals 1. So we would say the two solutions for that equation would be -5 and 1. I'll show you more in depth when we actually start solving equations, okay? So steps to solve. So when you have a quadratic equation and you're going to solve by factoring, so I'm going to put steps to solve by factoring just so we're abundantly clear. 1, if necessary, rewrite the quadratic in standard form, which is ax squared plus bx plus z plus c equals 0. And we do this by setting one side equal to 0. Okay. Step 2, we factor. So whichever side is not 0, you factor it. Let me see if I can. There used to be a way where I could like scroll here, but I don't see it anymore. So step 3, we apply the 0 product principle by setting each factor equal to 0. How do I scroll this up? There used to be a way where I could scroll up. This is why I don't use this as often. Anyway, by setting each factor to 0, and then we solve. Okay, so I'm sorry I scrunched that in. That was like a shame on me moment. But steps to solve by factoring, the first thing we do is we rewrite the quadratic equation in standard form. That's where we have the squared term, the linear term, the constant term, and we set it equal to 0. A good word to the wise is when you're doing this, set it equal to 0 in such a way that the a term stays positive. It just makes life easier. Okay. After that, we factor the side that's not equal to 0. Then we apply the 0 product principle by setting each factor to 0. And then step 4 is we solve. Okay. And again, I'm sorry I ran out. I used to be able to scroll up and down. I legitimately don't remember how to do that. And I just keep making marks on this. We're just going to leave it be. Okay. So that's how you solve. Let's actually practice. Okay. So the first example, the directions are going to say solve by factoring for each of these. And the first example we have is x squared minus or plus 3x minus 18 is 0. Now, the first step is, if necessary, rewrite and put this in standard form. We do not have to follow that step here because our equation is already in standard form. We have the squared term, the linear term, the constant, and then it's equal to 0. So, sorry, water break again. So we want to jump straight to factoring this. Just don't forget you're still equal to 0. All right, so we're going to set two binomials. We're going to multiply two binomials, set them equal to 0, and we're going to start each binomial with a factor of x, okay? So then I'm looking for factors of -18, okay? So one positive, one negative factor, and I want those factors to add up to 3. So I could do -18 and 1. I could do 18 and -1. I could do -9 and 2, 9 and -2, -6 and 3, or 6 and -3. So hopefully as you're going through these factors, and you don't necessarily have to write them out like this is just how I keep track of them and how I teach it, but hopefully as you're going through each set of factors, you're like, that does or doesn't work, and you kind of get to the point quicker. But this doesn't work, this doesn't work, this doesn't work, this doesn't work. This is close, but ultimately it doesn't work. So this is the one that's just right. 6 times -3 is -18, but more importantly, 6 plus -3 is also +3. So I'm going to put in a +6 and a -3. Okay, so we were already in standard form. We didn't have to perform step 1. Step 2, we factored the side that's not 0. Now, step 3, this is where we apply the 0 product principle. Sorry for the coughing. I haven't talked much today, so it's just a little scratchy. All right, so we're going to apply the 0 product principle, and the way we do that is we set each of our factors equal to 0. So I'm going to set x plus 6 equal to 0 and x minus 3 0. Because remember, if you have a product that equals 0, one or both of your factors has to be 0. So we just set them both equal to 0 and solve. So for the first factor, I have x plus 6 equals 0. I'm going to subtract 6 from both sides. 6 minus 6 is 0. X plus 0 is x. 0 minus 6 is negative 6. Now for the second one, I'm going to add 3 to both sides. Negative 3 plus 3 is 0. X minus 0 is just x. 0 plus 3 is 3. So at this point, I would say that my solution set contains negative 6 and 3, but I do want to show you how to check your work. Now, I'm not going to check every problem just for the sake of time, but I do want to at least show you how to check your answer, generally speaking, okay? So what you do, I'm sorry, you take your original equation and you plug in the two values for x one at a time. So I get negative 6 squared plus 3 times negative 6 minus 18, and I want to see if that equals 0. I will also check 3 squared plus 3 times 3 minus 18 equals 0. So for the first one, where we plug in negative 6. Negative 6 squared is 36. 3 times negative 6 is negative 18. Drop down your negative 18. We want to see if this equals 0. Well, 36 minus 18 is 18. 18 minus 18 is 0. 0 equals 0. So negative 6 is definitely good. Now repeat the process when x is 3. 3 squared is 9. 3 times 3 is 9. Drop down minus 18 equals 0. 9 plus 9 is 18. 18 minus 18 is 0. 0 equals 0. So we have checked, and we can say with confidence our two solutions are negative 6 and 3. All right, let's try another one. So again, we're going to solve by factoring, but this time we have x squared minus 6x equals 16. Okay, so hopefully you notice here that this is not equal to 0. So our first issue is this is not in standard form, and we want to put our equation in standard form by setting it equal to 0. I want to keep my squared term positive. It just makes life easier. So I'm going to subtract 16 from both sides. When I do that, I get x squared minus 6x minus 16 equals 0. Now I'm in standard form. So what I want to do is factor. I got my two binomials equal to 0. I'm going to start each with a factor of x. And now what I want to do is I want to look at factors of negative 16. This is important that you put this in standard form first, because if you didn't put this in standard form, you'd say, oh, my constant's positive 16, and you'd be looking for the wrong factors. But really, your constant is negative 16. So we want factors that have different signs. We could use negative 16 and 1, or we could use 16 and negative 1. We could use negative 8 and 2, or 8 and negative 2. We could also use negative 4 and 4. So we want to find the single pair that adds up to negative 6. So just to kind of cut to the chase, doesn't work, doesn't work, doesn't work, but almost doesn't work. So the one pair of factors, I'm really sorry about the coughing. The one pair of factors that works is negative 8 and 2. So negative 8 plus 2. Now we apply the zero product property. So we do that here. Okay. I'm going to set each factor equal to 0, because remember, if you multiply two things and their product is 0, one or both of those things has to be 0. So we're just going to set them both to 0. So x minus 8 equals 0. I want to add 8 to both sides. Negative 8 plus 8 is 0. X plus 0 is 0. 0 plus 8 is 8. For the next one, I'm going to subtract 2 from both sides. 2 minus 2 is 0. X plus 0 is 0. 0 minus 2 is negative 2. So I can say here with confidence the two solutions are 8 and negative 2. Okay, so that is solving by factoring. So I do want to highlight the two solutions here. Now, if you want to check your work, you could check your work here for the second example. You would take the original equation, which is right here. Anywhere you see an x, you plug in an 8, and then you'd repeat the whole process by plugging in a negative 2. If you get both sides to equal 16, you're good to go. You can say those are your solutions. Okay, so that is solving a quadratic equation by factoring. Let's now look at method number 2. We're going to look at solving a quadratic equation using the quadratic formula. Okay, there we go. So solving a quadratic with the quadratic formula. You either love it or hate it. One thing I will tell you is to solve a quadratic equation by factoring, it has to be a factorable trinomial. With the quadratic formula, it works on everything. So you can get the pretty solutions, the horrible solutions, it kind of always works, all right? So let's get back to the definitions here. We have the solutions of a quadratic equation in the form ax squared plus bx plus c equals 0 are given by the quadratic formula okay? And the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the math department is pretty set on you all memorizing formulas, and you will use this one a lot, okay? So do work on memorizing this formula right here. This is the quadratic formula. This is used to solve any quadratic equation that is written in standard form. So it really does have to be in standard form where you have the squared term, the linear term, the constant, and then that equal to 0, because in this formula where you see B, A, and C, that's assuming your quadratic is in standard form, okay? So let's look at an example. So we're going to solve using the quadratic formula. I will tell you this, if you have a factorable quadratic equation, it's a heck of a lot easier and quicker to solve by factoring. But remember, you don't always get a factorable quadratic. So sometimes you have to use the quadratic equation. So don't think you can cheat the system and always use factoring. Okay, so what I like to make note of when I have a quadratic equation is I like to make sure I'm in standard form, which I am here, and then I figure out what A, B, and C equal. Okay, and I'm going to rewrite the quadratic equation or the quadratic formula here. We have the opposite of B, that's what we mean by negative B, plus or minus B squared minus 4AC all over 2A. All right, so I've already figured out what A, B, and C are. I'm now going to fill in the quadratic formula with those values. So negative B just means literally what is the opposite of B? Well, in this case, B is 2. The opposite of B is negative 2. Plus or minus regular old B squared, so 2 squared, minus 4 times A, which is 8, times C, which is negative 1. All of that is over 2 times A, which is 2 times 8. So just fill the numbers in first. Then start working on the square root, or what we call the radical. Okay, the radical is the square root. The stuff under the radical, we call it the radicand. Start simplifying that. So I get negative 2 plus or minus under the radical. 2 squared is 4. And then negative 4 times 8 is negative 32. Negative 32 times negative 1 is positive 32. And all of that is over 2 times 8, which is 16. So keep going. We get negative 2 plus or minus under the radical. 4 times 32 is just 36. All of that over 16. I'm going to move things over here. X equals negative 2 plus or minus. Well, can you evaluate the square root of 36? Absolutely. The square root of 36 is just 6 all over 16. Now, what in the world is this plus or minus? It literally means plus this and then subtract this. So you literally add the two numbers on the top and divide by 16, and then separately you subtract the two numbers on the top and then divide by 16. So I get negative 2 plus 6 over 16, negative 2 minus 6 over 16. Well, negative 2 plus 6 is 4. 4 over 16 is 1/4. Negative 2 minus 6 is negative 8. Negative 8 over 16 is negative 1/2. So the two solutions here would be negative 1/2, comma 1/4. And that would be your final answer using the quadratic formula, okay? Now, for the skills we have at this point, we don't know how to factor this, okay? So you would be bound to use the quadratic formulas to make sure you know how to use it, all right? Let's flip the page and look at another one. All right, so again, solve using the quadratic formula. We have, whoops, let me go back to black ink. We have x squared plus 5x plus 3 equals 0. So A is 1, B is 5, C is 3. We were already in standard form, so I didn't have to do any work. I do need my quadratic formula. So I get negative b plus or minus the square root of b squared minus 4ac all over 2a. And now fill this formula in with your values for a, b, and c. So the opposite of b is negative 5 plus or minus the square root of b, which is just 5 squared, minus 4 times a, which is 1, times c, which is 3, all over 2 times a, which is 1. So I get x equals negative 5 plus or minus, under the radical, 5 squared is 25. Negative 4 times 1 is negative 4. Negative 4 times 3 is negative 12. And then that's all over 2. So x equals negative 5 plus or minus. Well, 25 minus 12 is 13. And then that's all over 2. Here's the thing. You don't want to take the square root of 13. Okay? The square root of 13 is 3.60555127, blah, 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 blah. So in a situation like this, if you have a most simplified radical, just leave it a radical. We can't break this down. There are no factors of 13 that would be perfect squares. So here is how you would write your answer. We get that x is equal to negative 5 minus the square root of 13 over 2, comma, negative 5 plus the square root of 13 over 2. And that would be your final answer. Okay, we can't go any further with this one. Okay, so for the last example, I want to show you one like this where you still have a radical in the answer, but the radical could be simplified. There's a factor of that number under the radical that's a perfect square that we can kind of pull out. So let's do one more example. So again, the directions are the same. We're going to solve using the quadratic formula. So we have x squared minus 2x equals 10. Well, if we go back a couple of slides, let me see which one, this one. The quadratic formula is used to solve any quadratic equation that is written in standard form. So the a, the b, and the c that are in the quadratic formula, they're dependent on the quadratic equation being in standard form. And if you look at what we have right here, this is not in standard form. So the very first thing I want to do is put this in standard form by subtracting 10. So x squared minus 2x minus 10 equals 0. And I promise you, if you follow my lead and just make sure you're in standard form, it makes your life easier, okay? Where you put it in standard form where the squared term is positive, that's what makes your life easier, okay? So I always move things and set it equal to 0 so that my squared term remains positive. Again, it just makes life easier, okay? So A is 1, B is negative 2, C is negative 10. And remember, x equals negative b plus or minus the square root of positive b squared minus 4ac, or not positive b, but just b, minus 4ac all over 2a. Now, in this case, b is negative 2. And this right here, what we're really asking for is the opposite of b. So if b is negative 2, what we would put is negative 10. This whole thing is over 2 times a, which is 1. So I'm going to bring things kind of up here. So x equals 2 plus or minus under the radical, negative 2 squared is 4. Negative 4 times 1 is negative 4. Negative 4 times negative 10 is plus 40. And that's all over 2. So we get 2 plus or minus square root of 44 over 2. Now, we don't want to leave this one in this form because if I think of 44, let's go over here to the side. 44 is equal to 4 times 11. And 4 is a perfect square. So I want to think of the square root of 44 as the square root of 4 times the square root of 11. We can't simplify the square root of 11, but we can simplify the square root of 4. So the square root of 4 is just 2, and then we multiply it by the square root of 11. And this is what we're going to replace the square root of 44 with, okay? So I get x equals 2 plus or minus 2 square root 11 over 2. Now let's clean this up a little bit. I can rewrite this as 2 over 2 plus or minus 2 square root 11 over 2. That is totally legal. 2 over 2 is just 1. And then plus or minus over here, 2 square root 11 over 2. The 2's cancel. 2 divided by 2 is just 1. 1 times the square root 11 is just the square root of 11. So my final answer would be 1 minus the square root of 11, 1 plus the square root of 11. And that's it. Kind of fun, right? Okay, so let me readjust and get back to you all. Okay. Whew, I look like I've been doing math for an hour and a half. Okay, so again, that is solving quadratic equations. There was a lot of buildup to that. Remember, we had to do some definitions, figure out how to multiply binomials. We then had to figure out how to factor quadratic trinomials where the coefficient on the square term is 1. That then led us to solving quadratic equations by factoring, and then the quadratic formula. This is not the easiest section ever. So if you're kind of like, whoa, that's expected. There's a lot that's going on, okay? But watch this video a couple times if you have to. Ask questions in class when you see me again, okay? But that's it for this section on quadratic equations. Again, if you have questions, just let me know. Good luck, all right? Take care.